Okay, let me start the timer. Um, what did I call it? It was countdown timer. And we'll set it for 20 minutes. Okay. So I had some thoughts of how to do this. But first things first, let's take all this code. We're going to paste it here, and we're going to rename it so that we can start hacking it up and making changes and not worrying. Some of you are probably cringing, being like, man, you should just use it in version control. But it's nice to have these nice snapshots because I have these small little working samples of different progressions, and I can also, take them and chop them up and use them in other places as well. So it's nice. And I had something I was going to name this. Yes, okay. So I'm just going to name it this. That's going to stand for dashed border. I don't really want to sully my, can I inline comments like this? I don't know if I can. HTML sucks, if you didn't know. Yeah, and here I am, teaching you how to do everything in HTML and JavaScript. Okay, maybe I should take that back. So HTML and JavaScript are great for getting stuff running really quickly for prototyping. So I'm not going to knock it there. I mean, before JavaScript and HTML5, I used Flash, and Flash was really good for getting stuff up on screen. So let's save this. I'm going to save it here. Dashed borders. Okay. I'll just take this and change my language. And full file path to clipboard. Gonna go up to the top here. Okay, so that's what I expected. Okay, we still got that previous functionality, and we press minus to zoom out, zoom in, zoom out. I was giving it some thought while I was walking around, and one way to figure out the math for getting the local tile coordinates is to try to simplify the problem by using an edge case, right? Literally solve the problem using an edge case as your example, because if you can solve the math for the edge case, then you won't end up with any problems when you encounter the edge case. And also the edge case sometimes is the most simplified version of the problem anyways. For example, the edge case we're going to use is, what if we are zoomed in so much on, what if we are zoomed in, actually I'm not going to use that edge case. I'm going to use the edge case of the destination viewport is looking at just one tile, right? Like it's, yeah. So we're like zoomed in so much that one tile fills the entire on-screen viewport. Because I think that is going to give us some help into figuring out the local coordinates of the tile. And I also want to take consideration as to how do we make this calculation in a way where the calculation isn't too lossy. Like, I don't want to lose too much information from like floating point rounding errors. So I do want to think about You got to remember that when you're doing formulas on a computer, it's not the same as like pure maths, right? There's only so many bits that are stored in numbers on a computer, and depending on how you code certain formulas, you might end up with weird artifacts, not because the math is incorrect, but just because of there's only so many bits of information in your variables, and rounding errors will just occur. Okay, so with all that ranting aside, I know I want a destination viewport, and let's say my destination viewport is only 4 by 4 pixels in size. So 4 by 4 pixels, and maybe space that out a bit. Just try to make a nice little square here. And so this is something that, you know, if I wasn't doing this to record it, I might just use some graph paper rather than kind of painstakingly draw this out. But it might be nice for having something to put in the comments later as well. So if we remember from earlier, the destination viewport is called VP0, and we should just keep that convention going so that we can easily know what we're talking about. All right, like I don't have to make a long comment about, you know, what that means, because we've kind of established what VP0 is. You know, we want to be more specific. You know, we want to say, you know, rec VP0. Okay, so our viewport is 4 by 4 pixels, which is ridiculously small. But we want to make this problem set, you know, manageable, so that we can visualize it, so that we can think about it. Because once we solve the formula, it's just going to scale to larger values. So now as for the edge case, right, I said I wanted one tile to fill the entire screen, right? So viewport 1 is actually just going to be it's just going to cover 1 pixel. So this is viewport 1 right here. That's VP1, aka rec VP1. And so the way we defined our rectangle, if the rectangle only covers 1 pixel, that means that x0, y0 is 0, 0, and then the end point is also the same. So x1, y1 is also 0, 0, because I'm coding my rectangles in that inclusive range kind of style. We could also make a note here of what the values we're working with are. Also, I think that maybe if I'm doing that, I might want to like put this down here somewhere, like, yeah, like that. So then I can write something like this. We can go write x0. This is just for ourselves. So we know that oh, okay, so now that I thought about it, I kind of lied about this one. This one might be at, right, because you could have a translation, right? So, but the idea is the both coordinates for the bounds of this rectangle are always going to be the same. They might not both be 0, 0 though, because it might be translated to somewhere else on the tile map. So maybe they're both 1, 1, or maybe they're both 1, 2. Maybe they're both 3, 4, right? But it's both coordinates are going to be the same for this because it only covers 1 pixel, right? So this is 1 pixel right here. Do I want to think about the translation aspect of this? Yeah, I guess we should. Okay. So, because we're mapping 1 tile to 4 tiles, we kind of know we can get the local coordinates of this tile by just looking at the coordinates of this rectangle here on the left, right? Because since this whole viewport just covers 1 tile, that means that it just so happens, coincidentally, that the coordinates here, right? So 0, 1, 2, 3, 0, 0, 1, 0, 2, 0, 3, 0. These coordinates just happen to be the local coordinates of this tile here, right? This tile or pixel, depending on how you want to think about it. Still recording? Okay. Still kind of thinking here. Let's just start writing down some numbers, because I am still kind of stumped, but I feel like if I started writing down some numbers, that might help. And in fact, it might also help to just write it as actual JavaScript, because I might be at a point where I might want to write it as code as I'm solving it, so that I can run it and kind of like check the math in the actual code. So we'll take, so we'll actually make a var rec vp0 like that, and I'll actually set those attributes. So let's start off with the simplest case of no translation, right? Let's just, because in the back of my head, I keep on thinking about, okay, what about the translation of these viewports? What about the translation of these viewports? Let's not worry about the translation first. So let's just assume that this viewport is at 0, 0, like its top left pixel is at 0, 0. So there's no translation. And let's assume that this tile is the first tile of the tile map. So it's tile 0, 0 in terms of its XY position, right? So it's 1 tile that we're zooming into all the way on this viewport. And we're not going to worry about the translation, because that's just another layer of stuff we kind of have to add to the logic. So we're just going to start off with solving the simplest thing we can solve, I guess, and move on from there. Since I am thinking of these as coordinates, maybe I should group it like this. So then x1 is going to be 3, and then the y1 is going to be 3, right? Because it's the first value is 0, 0, right? And so 0, 0, 1, 1, 2, 2, and then 3, 3 down here. And then you can close that off. We're not going to worry about object.seal on this, because this is just going to be a little snippet of code where we're just trying to solve what's going on here. We can't really write the other block over here, right? Because now we're actually writing real code. So we'll take this, and we might, if we want to, like, you know, structure it in a way where we can, well, that's going to be, I apologize that you can't. Okay, so I might have to format this in a slightly different way, just so that it's going to be kind of formatted in more of an ugly way, but I want to do that so that you can actually see what's going on here on the screen. So this is not the way I would usually format code, but the vertical space is kind of important right now because of just the way that, you know, just the way my cameras are set up for this recording. So I want to preserve some of that space. So for me, like, this to me is ridiculously hard to read. Right, so let's, maybe if we group these like that, maybe that'll be a little bit easier. It's difficult for me to read also when I glance at this. Like, I can't at a glance know if there's a proper amount of X's and Y's, and if there's a proper amount of zeros and ones in here. Like, I can't just glance at it and be like, alright, there's an X0. Actually, there's not, because these are both the same coordinate. So this is supposed to be X0, and this is supposed to be, you know, Y0, right? So X0, Y0, X1, Y1, right? And then, but if it's formatted this way, right here, right, it's very easy to just look at this and be like, oh, you got 2 zeros right here, oh, you got 2 ones right here, XY, XY, and you're done. You can instantly see that all the data is correct. And it's kind of why I have this kind of OCD formatting thing, because due to the halting problem, you can never write a piece of software that can be 100% certain that there's no errors in the program. So yes, tests will kind of like reduce the probability that there's errors in your main code, but then your tests might have errors. But the idea is that you just want to, when you're writing tests, you're just trying to reduce the probability that there's errors in your main code. But your tests might have errors in them as well. But then you don't want to write tests for your tests, blah, blah, blah. You don't want to do that. Anyways, let me try not to rant too much. Let's reformat this rectangle as well. So we're just going to move... Well, we can have everything kind of line up as well. Right, like... Let's try to make the most of this horrible formatting by being able to use it as a way to visually diff both of our rectangles, right? So that we can look at both of them at the same time. And I think I just did this and it was pointless because these are both the same values. VP0, so VP1 is just all zeros, right? Yeah. Because it's the first tile, and it's only covering one tile, right? So the viewport that looks over the data set is only wide enough to see 1 pixel. Or instead of pixel, like again, I could say 1 tile. So when I say tile or pixel, I may be using those interchangeably just because of the way I'm abstracting the problem. So I apologize if there's some confusion because I keep on saying tile sometimes and then other times just say pixel. But just try to get this idea that a pixel and a tile are sometimes the same thing, because the data set here where we're storing all of the tile values, we're storing that as just a bitmap, right? And then every different colored pixel in that bitmap represents a different unique tile. Okay, so we got our X's, our Y's, X's, and Y's. So with these two things, we want to be able to take a I'm concerned about I think the easiest way to do this is start with the destination coordinate. So a destination coordinate being a coordinate on VP0, the destination coordinate being where is that pixel going to actually end up on screen on the on-screen viewport. I think it's going to be easiest to start off with the destination coordinate and somehow derive the local tile coordinate